bad thing though. I think it's a good one.
Yeah.
There are no chairs.
So Alright, so I guess I'll get started. This is Introduction to iOS Programming, Session 1. So if you're here for something else, you're on the wrong room. Android, I think, is somewhere else. In this first session, it's going to be very beginner level. You won't have to actually write any code. So if you've actually done any programming in iOS, this session you could actually skip if you wanted to. Or you can just, because we're just going to talk about Swift and the main sort of programming paradigm that is used in iOS. Okay. And so with that, I'm started. So we're going to talk a little bit, just a bit overview of what iOS is, and the requirements you need on your computers to be able to develop an application in iOS. And then we're going to go really over into Swift and the programming model. All right, we're going to use Swift instead of Objective-C because that is what is being transitioned to in terms of Apple. Objective-C is sort of being phased out. And Swift is actually easier to pick up from a beginner sense, given it's has a lot of modern programming language constructs. So, first up, what is iOS? Well, it's Apple's mobile operating system. Powers macOS 10, the iPhone, iPod Touch, the iPad, and Apple TV. It's based on the OS 10 kernel, which has been around since the mid-90s, or 2000, I guess you could say, when OS X came to fruition. But in its mobile form, it's been around since 2007, and the latest one has been iOS 8, which was released last year. It was 2015 already. What this means for developing iOS is there's been 7 years in the mobile platform of it being refined, making it easier, sort of making it more efficient for coders like you to do so. So that's really all I have to say about it. If there's any quick questions, I can take that. On that, I'm just going to move on to the main parts of the talk. So next up, requirements. Well, you need a Mac. Ideally, you'll have 10.10 Yosemite installed, although earlier versions should still work. I'm not sure about the backward compatibility of Xcode 6, but there's really no reason not to have 10.10 since Apple now releases their operating systems for free. With that, you also need Xcode. The latest version is version 6. That should be, I don't know, that wasn't there. Is version 6. It is for free on the Mac App Store. Hopefully you all have that, given it is a big download and it takes time. So if you don't have it installed already, you're going to be back by probably about an hour, hour and a half, if the network's good. And considering the volume on it, I would have doubts. And then with the Xcode download also comes the SDK. So you're going to need that as well. That includes things like the iOS simulator, UI kit, the frameworks, and also a lot of documentation, which is very useful. Although that documentation is available on the internet, so if you don't have a network, though, you're going to want to have it downloaded. I think I mentioned that. Oh, one last thing I want to mention. If you have a Hackintosh, that would still probably work, although I can't say for sure. But I'm guessing if you had a Hackintosh, it would still work. And let me go. All right, and then ideally you'll have some type of program experience. I believe this track is marked as intermediate level. So with that, we're assuming some program experience. I don't know if you guys saw the sheet that went out, but hopefully you guys have at least had a 100 level programming course. Ideally 200 or greater, given the concept that we'll sort of be going over. And if you've had experience with any of those languages, you'll have a head start over someone who hasn't. Most importantly would be Swift and Objective-C. If none of you have experience with Swift, that is completely understandable, given that language itself is very new, just came out mid last year. And it was a successor to Objective-C. These are great languages. They're not like Java or C# in the fact that they do not run on a virtual machine. they are actually compiled down to C and then down to assembly language. That's one of the things that makes iOS such a powerful operating system and platform to code in, is that you actually get the performance of having a native application without the overhead. But with that, you also don't have garbage collection. So for anyone who knows from Java or C# what garbage collection is, it's, you allocate memory, you suddenly stop using it. Well, you're either wasting memory, but the garbage collector comes around and frees it. iOS doesn't have this. What we do instead is something called automatic reference counting, which I believe is better because it takes out the overhead necessary for having a garbage collector. And what it basically is compiler optimizations that actually examine the scope and lifetime of your variables, and then automatically call the freeze for you to free up your memory. Yeah, and then, like I said, basic programming, so variables, functions, control flow, etc. I'm not meant to teach programming 101 here. And I should slow down because it's really quick. Where is the pace guide? Here's, okay. All right, so let's get to the main stuff. Programming iOS overview. Like I said, we're going to talk about two things. Swift, which is the language. We're just going to give an introduction to it. So we're going to go over basic syntax, arrays, dictionaries, classes, control flow. Things that if you've programmed before but have never seen Swift, this should get you up and running in Swift. And also, if you look online, Apple publishes a great document, the Swift programming language. I guess every language has it. C# has it, the C# language spec. Java has it somewhere, sort of the Java docs. But you can feel free to look it up on your own. All right, so let's go into Swift. Swift, it's a new language released along iOS 8. Like I said, this is mid last year, so it's very recent, especially in terms of programming languages in length. I mean, you look at something like Java has been around for the better part of 20 years, C# as well. Objective-C was around for, I think, longer than that. Swift is very new. But what you get with something that's new is you get a lot of the inefficiencies taken out of these older languages. So what they did is they took the best parts from sort of all modern languages and tried to merge them into Swift, and I think they did a good job with it. Your mileage may vary. And so here's the basic hello world example. This would be the equivalent in Java to system.out.println, or if you had C#, console, or just printf and C. And then you have a less basic hello world. Here you have an introduction to variable declaration, strings, functions, and function calls. All right, so this is just, basic hello world. So, variables and constants. So, there's no explicit need to call types when you declare a variable. So, as you know, in any programming language, when you want to use a variable, you have to declare it first. In Swift, we do that with the keyword var. All right, so if you look at the top, var str equals hello Swift. What that is assigning the string, which is denoted by those closed double quotes, to the variable string. Now, how do we know it's a string? Well, the compiler, based on what it's assigned, actually interprets the type. So there's no need to explicitly say the type. It's interpreted. But that doesn't mean that doesn't mean you can't if you want to. If you wanted to, right after the name, you do a colon, and then you put your type. And then you can initialize it, or you don't have to. If you don't have to, you need to put the optional key symbol, which is a question mark. And we'll talk about optionals in the next session, because optionals is a relatively advanced topic for what we're going to do here. Okay. So what you should take out of this is anytime you want to use a variable, use the keyword var, and give it a default value would be the best thing to do. Now, if you want to declare a variable that doesn't change, so it shouldn't be called variable, it's called a constant. Constants, if you're familiar with C, you have the const keyword. In Swift, we have let. which is anyone who's dealt with, I guess, paralysing is the closest one that deals with the let keyword. F#, I think, also deals with it. But just like variables, their types are inferred, but you can only assign to it once. And if you have a constant and you try to assign to it a variable, it's to try to assign a variable to it later on, you're going to get an error at compile time. But that being said, you don't have to give it its value when you declare it. You can just declare it and then give it a value someplace else, but you must only ever assign it a value once. Okay? So let is for constants, var is for variables. What if you had a lot of variables? Oh, I pressed. Sorry. If you want to declare an array of variables, Swift also supports arrays. Here's the syntax. This declares an empty array. Anyone want to guess what its type would be, just from the declaration? It actually doesn't have a type right now. It's just memory for an empty array. You might be able to get any object out of this, but most likely it's not going to be declared as anything until you actually insert something into the array. Okay? If you want to initialize an array that can have any type in it, you can do this. Okay? Now, there's a difference between these two. This, the top one, explicitly declares what type of variable is going to be in that array. So if I tried to then add a string into array 1, it wouldn't let me. It would be a compile time error. But if I wanted to insert a string into array 2, then it'd be just fine. So that's what the type bracket is for. Otherwise, yeah, fine. Accessing an array, Swift, just like in C or Java, you have the square brackets and its indice numbers. Arrays are 0 based, so that is the first element is element 0. And this number must be in range, or you will get not a compile time error, but you'll get an error at runtime where your program will just crash. Anyone who's done C and seen segment faults because of out of bounds, that's what you'll get with this. Guess that's the downside of not running on a virtual machine. And then if you want to modify something, take its index and then assign it to something. Yet again, that index must be within the range of the array. Okay. Is everyone clear so far? Any questions? This question.
Would you use semicolons with these declarations, but not with the ones before?
Oh,
if you declared with the first variables, you'd have to use a semicolon, but with these ones you do.
Right. Yeah. No. So if it were, I know I grabbed this out of. I wrote this out of the. I took this out of my code. That might be a typo. Okay. So I'll check that.
Semicolons or not?
What? Oh, you mean at the end of the lines?
Yeah.
Oh, okay. You don't need semicolons. One thing I forgot to put in this presentation. Thanks. No, semicolons are not necessarily at the end of the line. So if you see back, there are no semicolons at the end of this one, and then here there are. I did that intentionally because you actually don't need them. But if you wanted to do multiple statements on one line, that's how you would denote the breaks. So if you're going to have different statements on every line, you don't need any semicolons. Yes.
For the second array where you don't give it a type before the equal sign, you said you could like insert a string into it. Do you mean you could insert a string into the same array, or you could set it like equal to a different string array?
Oh, I could insert it. Well, you could do both.
So you can have an array with like different types of elements in it.
Right. So I could, if I reassign this variable to be a string array, you could do that as well. Or if I just wanted to insert a string as, let's say, the third element, you could do that as well.
Is there a way to, I mean, like how int specifies it so it's only ints, is there a way to specify it so it's like only two different types of variables, I guess?
I don't believe so. Questions? Okay. The next structure is dictionaries. Does everyone, all right, give me a show of hands. Do you guys know what a dictionary is? Okay, so not many hands. So a dictionary is basically a mapping between a key and a value. So they're accessed in the same syntax of an array, except instead of having an index number, you have the key that goes there. Okay? So it's basically a storage, and keys have to be unique. So I could not insert another element into this dictionary with also the key. It has to be something else. Okay? Or if I wanted to have an empty typed dictionary, same type of square brackets with the type in it. Accessing it, dict1 would be dictionary, and then I want the value associated with this key. If this key is not in the dictionary, rather than giving an error, it will just return nil. And if I wanted to assign, just like an array, if it doesn't exist, it will be added. Okay, so dictionaries are safer to work with, but you shouldn't use them in place of an array just because of their safety. Okay. Any questions on dictionaries? And if you look in the documentation, there's a lot of methods on dictionaries. Like you can get all keys and enumerate over those. You can get keys for values, insert, modify, delete all. But any questions? No. Okay. Okay. Functions declared with the func keyword. Right. So here's a basic function. All it does is print my first function. So you see it's declared func keyword, and it's given a name, and then open close parentheses. If you wanted to return something out of a function, at the end you use this arrow symbol, or it's it's that single dash and then greater than caret, and then the type that's going to be returned. Okay? So func magic number returns 42. 42 is going to be of type integer.
You need to specify the type?
Yes, you do. That being said, you can also call any object as a type. So I'll talk about that when I get to classes, since we cover that. Okay? But functions aren't always going to be useful if you can't pass them variables. So when you want to declare an argument to pass, you use the name, the type, and they're comma separated. Okay? Now you can have actually variable length arguments, but only one of them can be variable length, and that would just be specified at the end of the ... So I'd be saying there's a variable number of integers at the end.
So the one parameter is an array, what would you call it? Right?
Yeah. So if it was going to be an array, then the type could actually be an array. Right. So I guess that's variable length arguments if you want, but you can actually explicitly call functions with different numbers of if they're comma separated. So yeah, good distinction there. This pound symbol is not necessary in a sense. If you're very beginner into iOS, just use this, because this allows you to then, when you call it, to actually use the variable and call it with the same name. So this just duplicates. It's the shorthand syntax. For what you guys will be doing, I would say always include that pound. And if you do it when you're not supposed to, your compiler will give you a hint of what to do, and it'll just get rid of it for you. So I wouldn't stress too much about that. Any questions on function declarations? Okay. For anyone who's had more advanced program experience, function is just a name closure. Swift does support closures, but we don't talk about that because that is a more advanced programming concept. Okay. Next up, classes. Who knows what a class is? And 2 people. Okay. So for those of you who don't know, a class is a single, think of it as a program, a very simple program on itself. It's a self-contained program. It has its own variables, has its own functions. Okay? And in object-oriented programming, which is what this is, you create classes, and then you instantiate those classes into objects, and then each class has a single responsibility. I believe it's called the single responsibility principle. There is a name for it that's pretty much self-explanatory. So if you want to declare a class, it's with the class keyword. Classes can have variables, just declared like standard Swift variables, and they also have functions, just like standard functions declarations. When you initialize the class, yet again, when you return it, it becomes an object. So it's var because you have a variable. I guess I chose E for this. I don't know why. And then this is the instantiation of this class. So what? Yeah, question.
So yeah, is self just like this in Java, I guess?
Self is just like this. Yes. Yes. So self refers to the current object. In here, this is actually not necessary, but it's not going to give you an error for doing that. My experience comes in Objective-C, and so it's always been kind of safe to do self. Okay. Any questions we're up to so far? Okay. Now, when you declare or when you instantiate a class like this, it calls it to init function. This init function, you don't actually have to write for a class. You could leave it empty. However, if you wanted to do any type of variable initialization when your class is created, then you would just specify an init function. Okay? So if I had a list of variables that I wanted to set to a certain value upon creation, then I would override that init function, which is what I'm doing here, setting the class variable to be 25. Okay? And if I wanted to call the function that is from that class, standard dot syntax, similar to C++, C#, or Java. Everyone understand classes? Or basic view of classes? Okay. With classes, you also have subclasses. So that is saying a class can inherit properties from another class. So the example I gave here, and this is very arbitrary, I thought this up in like 5 minutes, I was in a rush, is let's say you had a class vehicle. Okay. Well, there are certain properties that would be general to all vehicles. How's an engine size? Is it hybrid? I don't know why I put true as the default value. I was thinking green. Okay. How many wheels does it have? Chances are 4, right? But these are all properties that can be shared among different types of vehicles. Okay? And let's just say there's a default description that when you call vehicle.print description, it gives you some message about the vehicle. So in this case, the base vehicle will give you this, this is a fuel efficient machine line. Maybe it's not true though. Truck wouldn't want to do that. But a truck is just a type of vehicle. So we can declare another class, which is truck, but using this colon syntax, we then can list its superclass. So a superclass is just what I inherit from, right? So think of it as parent and child. Questions up to this far? No? Okay, go ahead. Start. Yeah. So a subclass would inherit all the variables and functions of its parent class or of its superclass. So if I wanted to call truck print description, if I didn't even have this declared here, and I realize it's a projector, so me doing that doesn't actually hide it, then it would just give me the function call that's declared in its upper. Okay? That being said, you can also extend a parent class within a subclass, right? And that's just listing additional variables. Yeah? If you wanted to override this function, because let's be honest, this doesn't apply to a truck, this statement, right? When I print description, of a truck, I don't want to say it's fuel efficient. So this override keyword is important in terms of classes. What override says is, even though there is a definition for this function in my parent class, when I call this, I want you to use mine. Okay? So that's the concept of overriding a function. Yeah.
And the superclass basically use variables that have inheritance.
No, it's a one-way inheritance, right?
What does override init mean if you don't already if the init function doesn't exist in the vehicle class?
Okay, the override. The init function does exist. Remember, I said you don't need to put it if you're not doing anything special. So the init function still exists in here, but it just think of it as empty braces. All it does is allocate memory, but it still exists. So if you want to do something with it, you have to override it.
What do you mean, like it exists, like it's just there, or like you find it?
Right. So let me go back to this one. So in here, I put the init function because I wanted to set this variable equal to this number.
Oh, right.
Okay. If I didn't want to do that, okay, then I could leave this init function here doing nothing.
Okay.
That's the exact same as if I didn't put this here at all, which is the default behavior. Okay. So even though you don't see it here, it still exists, but it's not doing anything useful. But here I wanted to do something useful. So I have to first initialize it to get the memory allocated for it, and then I can do some initialization. That being said, if I didn't want to do any of this, I wouldn't have to call this at all, or I wouldn't have to define this. Okay?
Do you have to, with subclasses, like in Java, do you have to use the extends keyword to,
No,
if you're making a whole?
just
Okay.
colon. Okay? And I guess I should talk about it in the second one. This is my second talk. In protocol and delegates, it's just still colon. So anything to the right is sort of a super / implement. So it's the equivalent of extends and implements. So I personally like this syntax better. Objective-C had it the same way for anyone who dabbled with Objective-C. So, any other questions on subclassing? No? Okay. If you have any, we can go back. No? Next, this probably should have gone sooner. Control flow, like any good language, there's your standard if statements, for loops. There is while and do, although you'll find in iOS programming, you mostly do enumerations, which is for, which is why I have 2 examples of for loops. And there's a switch statement, which can't really see that well. And I apologize for the color scheme. I'm going to change that for my third talk. So standard if statement syntax, you can, if you come from a C background or Java, put parentheses, but they are not necessary. So either way, how you want it. So you have your standard if, and else. So does everyone know how if statements work? Okay, if you don't know how if statements work, raise your hand, I can explain it. Okay, so an if statement is just a decision that the program makes. Okay, so forget the first line of you knowing what the variable num is. Okay, all you know is num is a variable. So program runs along, comes to this if statement. If num equals double equal sign, which is equal to 42, then I'm going to execute what's inside those braces. Okay. If num is not equal to 42, then I'll look at the next else if statement. Oh, is it equal to 0? If it's not, then I'll either break out if there's no else statement, or else we'll catch everything that's not caught from above. Okay, so it's simple decision making. For loops can be declared just like in C. Yet again, though, these parentheses aren't actually necessary. So it's initialization, condition, and then increment. And you can also have automatic enumeration of types like dictionaries and arrays. So as you can see, nums here is an array of numbers. So for number and nums, what this is going to do is for every number that exists in this array, it's going to print it out. So single selection. So the first time through, number is going to be 1. The number is going to be 2, 3, 4, 5, 100. Right? So it's fast enumeration. Similar to for each from languages like C#. Yeah.
So are those like two? Is there like it's kind of hard to see, but are those like two lines of code on the same line?
2 lines of code. Which
Or
one?
is that like a whole separate section? Like for instance.
Oh no, these are separate.
Okay.
Yeah. Any other questions? Okay. And we also have switch statements. Anyone who comes from a C background is going to appreciate this just a little bit. If you don't come from C, you'll appreciate it as much. So switch basically introspects this number, and then depending on what matches, is going to execute that that set of statements. Okay. So this syntax is if num is between 0 and 49, including 49. So if it's 0, 1, 2, 3, then 47, 48, 49, then the statement will run. If it's between 50 and 99 inclusive, the statement will run. And there's also a required catch-all to, if nothing is matched, to do something. This can actually be left blank, but you're still required to have it declared. As saying you want to do nothing. Okay.
Is that last case default? Is that what it says?
Yes, default. Yeah, I'm sorry for the colors.
I don't know, front lights, you can turn it off, maybe you can.
Yeah, maybe. Someone want to try the front lights? Is it labeled? But should put more down then. Better? I'm gonna try that one. Better? Yeah.
Can a case hold more than one line of code?
What?
Can a case hold more than one line of
Oh, yeah, there could be a bunch in here.
code? How do you separate? Do you do like colon bracket?
So this colon at the end symbolizes the start. Okay, and the next case it encounters is the end of it. Okay, I mean, this seems to work. Cool. Any other questions? Okay. Anyone who's programmed in C will know from C that there's usually a break statement here, because otherwise it will fall through. In Swift, there's no break statement that is necessary. It won't fall through at all. So by default, it ends. If you want it to still fall through, there's a keyword fall through, which you can specify. But if you guys haven't dealt with C and switch statements, then forget everything I just said. That'll probably confuse you a little bit. That's going to sum up the Swift part of this talk. If you want to go here and get a lot more information and read a bit, I encourage you to. But what I give you should be sort of enough to sort of get your ideas going of what you have to do if you write it on it. All right. So next up is a programming model, which is model view controller. Has anyone heard of model view controller before? Okay. All right. So model view controller is a software architecture style, which the concept of it is you break your application into 3 distinct parts, right? The model, the view, and the controller. Programs aren't very creative with their names for things, right? So here we can see the relation between model, controller, and the view, and their relations to each other and also the user. All right. So first up, model. So the model is the logic of your application, right? It's responsible for knowing state, variables, any type of manipulations to your data. All that is represented inside the model, right, abstractly, okay? It does not know, nor should it care about how the user sees that information, okay? So it's removing the logic from the viewing of it, right? So what this gains you, apart from it's actually easier to write your program because you break it up into smaller parts, is you can then, let's say you wrote a really great application for iOS, but then you wanted to port that to, let's say, a desktop application. Well, if you had all these, your models and your views intertwined, it would be very hard to extract your logic and move it over to a different display setting. But if you break up in model view controller, you can simply take the logic of your code, copy those files, and then implement a different view and different controller code to be able to easily port your application up other places. So I believe that is really the main sort of go for model view controller. Next is the view. Some could argue this is the most important part of an application, given it's what your user actually sees and interacts with. It doesn't know anything about the logic behind the code. All right. All it knows is I'm going to display text here. I'm going to display an image here, right? I'm going to have a button here that the user can push, right? I don't know what the button, it doesn't know what the button does. All it knows is I have a button here that displays something. Okay? Any interactions that come to it from the user, it doesn't act on them. All it simply does is pass those on to the controller. Also, the controller tells the view what should be displayed in those areas. All right? And then, of course, the view will then update and display what it needs to the user. So the view is only responsible for displaying the data, regardless of what that data is. Now the most important part of the model view controller, the controller part. It's the actual glue of the application, right? It's what connects your model to your view, which makes your application run. So let's say you had an application that did something when a user hit a button. Right? So let's say it updated some value. So the user would interact with the view, and then the view would get its update. Oh, there was a button push. Well, what do you do with that? By model view controller, the view can't say, okay, I'm going to increment this counter in the model. Right? That's not allowed. So what you do is the view tells the controller, because the controller is allowed to interact with the model. So the view tells the controller, hey, there was a button push. With this information, the controller can then say, okay, I don't care about that button push. Or, oh, I need to update the model. So I need to tell the model that there was a change. In which case, the controller would tell the model it needs to change. The model would then update the controller, at which point the controller would then change the display of the view. Okay? So arguably, this is the most important part of your application. And in iOS, this is actually some of the easiest part you'll actually write. All right, so iOS actually does a really good job about separating out your model from your view from your controller. Okay? Any questions on the basic idea of model view controller? No. So just let's do an example of model view control. Let's think about a simple calculator app. All right, so I actually have one here. Just turn this right on. Okay. So let's change preferences. Yes, much better. Look at that. Okay. So what do we want in a basic calculator app? Well, let's say it took two numbers and it could add, subtract, multiply, and divide them. Right? Very basic. So the logic of the code, well, it needs to maintain two variables, which are your inputs, and then also the answer. All right? So, oh, here's a class declaration actually in existence. So notice you have the function, add, subtract, multiply, and divide. Right? And they do accordingly with the input numbers. But notice there's no user interface in this at all. Right? This is just purely the logic code, which by model view controller is what we want. Because if we wanted to put this on a phone application, its interface would look different than if we had it on the PC. What about our view? Well, in iOS, we have this interface builder / storyboard, which is where you lay out your view. This is the easiest part of iOS programming, just laying out the view. Right. So all this is these are 3 text fields. The top 2 can be edited, and that's a button. So the view was laid out. Clearly, there's no logic in this. In fact, this is not even code. Right? This is just a layout of objects on the screen. But this is what constitutes your view in iOS. Right? It's a simple layout. And here's our controller. Notice it has references to things displayed on the view. Right? It also knows about the logic of the code. Right? The main logic, the basic calculator. Right? Oh, no, I have this here. That shouldn't be here. Yeah. And I've only implemented the add function on the controller. I got lazy. Figured this should be enough. So, if I look into the view, this button right here, if I see this touch up inside, all right, it's hard for you guys to probably see this, but this bit right here, this is a connection. Okay? And what that connection is let me just do this. So see that magic blue wand? This is what you do to notify a controller of an event that happens in the view. All right, to drag out, you'll notice that add function, which exists inside the controller, is listed there. I just connect it up like that. Make sure it's still there. Yep, good, connected. So whenever that button is pushed, it's going to call this function. This IB action is, we'll talk about it in the next slide or in the next session. It's basically how you define an actionable, something that comes from the interface and function. And what does this do? Well, it sets the 2 numbers of the logic, right? The view is not doing it directly. This is the controller doing it. It sets it to the value that was in those boxes. It calls add, right? Yet again, this is telling the model to update. Because if we looked at the model code, right, when you call add, it updates the solution variable, right, from the 2 input numbers. And then the controller tells the view, hey, change your solution format text to be the actual solution. Standard string formatting from various languages. That's mostly the same. And if we were to just run this application, demo never seemed to. Oh, really? Or I could just crash. So that. Okay, now it says so. So we put in 2 numbers, 23 and 21. Just add 44. Right? Very simply, we had our model code, which simply implements a series of functions. If we ever wanted to extend our model, we wouldn't have to care about what was being displayed to the user. So we could implement, let's say, a squared function without ever displaying that to the user, not having to care. Okay. The view, which was just the inputs and the buttons, and then we tied it all together using the controller. The controller was notified of any updates to the view, and then in turn updates the model, and then gets the result and gives it back to the view. And with that, we conclude this session. Right on time, actually. I was told to go 45 minutes. Any questions? Right. Session 2 is going to be more in depth. Yeah.
Yeah, sorry, dozing off.
Easier? Yes. It is. It is. So, so I guess you weren't here, but so all of you controllers and programming paradigm we should all be using. This is what it looks like in iOS, right? Clearly, I have a model class. Right? My view is laid out here, and this is my controller, which connects the two together. That's it. It's that simple. It's that easy. If you deal with Android development, how these XML files, your view and your controller kind of get mushed together. Your pointer passing around is a little sloppier because of Java. In my opinion, the iOS development platform is first class. So, your monitor.
Oh, can you explain at the very beginning? You said you said because like it doesn't have a trash collector. I forgot what word you used to describe
Oh,
it.
automatic reference counting.
Not, I mean, but the reason it doesn't have that, you said like it compiles in like a higher up language, and that compiles in a different language as opposed to like.
Right. Okay. So if you look at a language like C# or Java, so C# runs on the Common Language Runtime, which is a virtual machine. Okay. And then Java runs on the Java Virtual Machine, the JVM. Okay. You may have heard these things before. Okay. So it's like an operating system for the programming language.
Okay.
So it sits on top of the OS, and that actually conforms. It transforms the C# code into actual machine assembly code. So, but the problem is to run a virtual machine, that's more resources, right? So that's another program running essentially. And
so it converts all the code straight from like our Java language into the machine language, and then reads that separately.
Right, exactly. So you have this thing that's constantly running. So that uses up resources. Now remember, iOS was made for mobile phones, right? This is from 2007. ARC, automatic reference counting, didn't come around. I think I want to say 2009 or 2010. It took a good 2 years for actually ARC to be sort of hammered out and developed. But what ARC does is it says, okay, everything the virtual machine is doing, right, keeping track of variables, we can actually do ahead of time by using a good compiler, right? Because if you look at code, you see you got curly braces to define scope, you have function calls, and what you find a compiler actually does is it will mainly inline your entire program. One of the first things your compiler probably does is takes a function call, takes the code of that function, and puts it inline in your code. Right? So the idea of don't write one long function as your program, that goes away on the compiler side. Because it turns out more optimizations can be done by putting things in line, more parallelism. Right?
By that, do you mean like same space and they can be like all next to each other and emulated, or?
No. I mean, so let's say you have this function multiply, right? Multiply number A times number B.
Yeah.
And let's say you use that a lot. Now, let's say you had a matrix multiply. So a series of multiplications, right? You would usually put that into a function call, right? Because every time you have to do that matrix multiply, you don't want to, write out all the matrix multiply. You just want to say, oh, function call, matrix multiply. One of the first things your compiler does is, oh, I'm calling matrix multiply. Let me put all that code in here. Right? It sort of undoes what you did to make functions.
Oh, you mean so if you have a function, you call it different from that function. It just puts all the code from the smaller function into the function.
Right.
So
but you can get a lot of optimizations over there.
Okay.
But what they found is when you do this, you can actually find and infer a lot of lifetime of your variables in that. So the compiler goes through and says, oh, this variable is never used after this point.
It's based on the number of times.
I can get rid of this, right? It sort of keeps count. Yes.
Hey, I had a question. So you said in the storyboard is the main storyboard is where you basically add the text fields,
Yes.
labels, things like that, and they show up. They're going to show up in .swift file. Right?
No. Well, so what you can do is, do you have any more questions on?
I don't really. I'm sorry. Like, is that the only real difference between the virtual machine versus the way iOS compiles?
Yeah, essentially.
Okay.
But you get a lot of performance benefit out of it. Well,
I have a PC. Should I just use Microsoft Azure?
Azure?
Yeah, Azure.
I don't think you can program iOS in that. Azure is a cloud platform. Yeah,
Would it be in Swift?
probably not.
It'd be something weird.
I don't know. I know you can do C#. iOS could do C#, but that's using Mac. But I'm not so sure that you don't have. I'm not so sure that process. So,
Okay. Would there be any other way to use Swift on a PC?
not that I'm aware of.
Okay.
Thanks.
Yep.
Any emails to sites so I can review before the next presentation?
I think Jen emailed them out.
When will we be? When was the email?
Right before this presentation. Okay, so back to your question.
So you had something to start. Text field.
Right. So let me get this out of presentation. Okay, so here's the. Actually, just here's our view, and then here's the view color. Okay, so let's say in our view, I wanted to drag out another button. Sure. So actually, so what I can do if I want to is
So when you put it on there,
no, but what I could do also, that magic blue one. So, okay, if you label reading outlet, we're going to call this. It's very separate. It's like, let me explain to you for let me text Jen because I think you're supposed to check it out. Yes.
it's like each big box, you have exactly the name of that button.
What do you, oh, so,
The game like all the game almost over.
okay.
So just like create like a grid button.
Yeah, you could. That's very possible.
All my average. So I'll let you up with I would lose track of that.